Hello, and welcome back to another IB Math Speedrun with me, Bits. So we're going to be continuing our exploration of different differentiation rules, and right now we're going to be looking at the chain rule. So let's jump right in. So what is the chain rule? Well, the chain rule is something that's useful if we have a function that's really two composite functions. Something like y equals x plus 1 times 2. So one way we could solve this is we could just simply, expand it to x squared plus 2x plus 1. But this, what if it's a higher power? What if it's not 2? What if it's, I don't know, well, what if it's to the power of 6? Or to the power of some power where it makes it very hard to expand the function and then differentiate it all. That's where the chain rule comes in. So if we split this apart, we could say y is actually equal, let's define this function u as equal to x plus 1. And then y is equal to u to the 6. If we have this kind of thing where we have two composite, a function that's kind of composite, then we can use the chain rule to easily differentiate it. And what the chain rule states is that the derivative of, dy over dx is equal to the derivative of this function, dy over du, multiplied by the derivative of the second function, so du over dx. So the derivative of this original function will be equal to the derivative of this multiplied by the derivative of this. Wow, very interesting. And so this makes it much, much easier to differentiate functions in this case. So it's, it's just the multiple of the two. Then dy over dx must equal, well, what's the derivative of this? This is 6u to the 5. What's the derivative of u? That will be equal to 1. So it's 6u to the 5, which is equal to 6 times x plus 1 to the 5. So we got through the entire, differentiation without, having to expand the brackets, and that's much, much easier. So we're going to be doing some questions that relate to the chain rule so that, you can help improve on it. So I'm going to be doing the odd questions. And the first question is a similar question. Y is equal to 4x minus 3 to the 5. So if you're doing this function, let's label u as 4x minus 3. And so y is also equal to u to the 5. So using the chain rule, dy over dx is equal to dy over du times du over dx, which is equal to dy over du, which is 5u to the 4, times du over dx, which is the derivative of this, which is simply equal to 4. So 5u to the 4 times 4, so the derivative will be equal to 20u to the 4, which is also equal to 20, and then let's substitute 4x minus 3 back into u. So it's 20 times 4x minus 3 to the 4. So that will be the answer. Okay, on to the next one. And the next function is this. It will be equal to y is equal to 2 minus x squared minus 3x to the 5 all over x. Do we have to use chain rule for this? I mean, okay, I guess. Okay, so what I would do in this case is this is equal to 2 times 1 over x minus, do we have to use chain rule for this? I don't understand why we would have to use chain rule for this. So I'm going to do it without it until I figure out why we need to use chain rule. So this is simply 2x to the negative 1 minus x minus 3x to the 4. So if we get the derivative of this, it's simply equal to negative 2x to the negative 2 minus 1 minus 12x to the 3. I don't know why we needed to use chain rule for that one, because that's just the answer over here. But okay, you know what? Fair enough. So let's move on to the next question. And the next question is, we have y is equal to 1 minus the square root of x over x to the 3. So let's label u as equal to 1 minus square root x over x. And so this is also equal to u cubed. So 1 minus square root x over x. Well, let's get the derivative now. dy over dx is equal to the derivative of dy over du, which is 3u2, multiplied by du over dx. What's the derivative of this function? Well, this would be equal to 1 over x, which is negative x to the minus 1, minus square root of x over x, which is simply square root of x. No, sorry, negative square root of x. So x to the minus 1 minus x to the minus 1 half. Well, what's the derivative of this? This is equal to negative x to the minus 2 plus 1 half x to the minus 3 over 2. So 3u squared times negative x to the negative 2 plus 1 half x to the 3 over 2. And then we substitute this original equation back in here. So we get our final answer as 3 times x to the minus 1 minus 1 half x, minus 1 half x, minus x to the negative 1 half squared times negative x to the negative 2 plus 1 half x to the 3 over 2. So it's that. Yeah. Okay. Yeah. Okay, next. We need to find the equation of the normal to the curve of y is equal to x minus 2 over x at x is equal to negative 1. Why do we need to use chain rule for this? I actually don't understand why we need to use chain rule for this equation. I feel like it will just confuse things. So, okay, I'm not going to use it. We need to find the equation of the normal at x equals minus 1. Well, this is simply equal, this equation is equal to 1 minus 2 over x. So the dy over dx will be equal to minus, 2x to the negative 2, since this is, of course, equal to negative 2x to the negative 1. And so we need to find the equation of the tangent of the normal at x equals minus 1. Well, 2 times minus 1 to the negative 2 is equal to 2. So the equation of the tangent is 2. I have a feeling we've done this question already. But anyways, negative 1 minus 2 over negative 1 is equal to 3. So this is the point negative 1, 3. And so we need to have y is equal to 2x plus c. Substitute this in. 3 is equal to 2 times negative 1 plus c. C is equal to 5. So we have y is equal to 2x plus 5 as our final answer. Mm-hmm. Yeah. Okay, on to the next one. So the next question is asking us, find dy over dx if y is equal to the square root of 2 minus the square root of x. Okay, so we can actually use the chain rule here. It's a valid question. So we would want to label u is equal to 2 minus the square root of x, and so we can say this is equal to the square root of u, or u to the 1/2 is what I prefer. So also making this x to the 1/2. Well, what's dy over dx? dy over dx will be dy over du, which is 1/2 u to the negative 1/2 times d over dx, which is equal to negative 1/2 x to the negative 1/2. And so this entire thing will be equal to 1/2 times 2 minus x to the 1/2 times negative 1/2 x to the negative 1/2. And yes, we could simplify this. This would be negative 1/4 times the lot. But yeah, that's pretty much it. So that's our final answer. And maybe in an actual exam you would rearrange the equation, but that's not the focus of this exercise, so I'm not going to. Okay, finally we need to, okay, so our final question is f of x is equal to 5ax cubed minus 2bx squared plus 4cx. So we need to find f prime, which is not hard. This is simply a, b, and c are constants, so we can treat them like any other constant. So we can say this is 15a squared, ax squared, minus 4bx plus 4c. Okay, so now given that the derivative of f prime, given that f prime is greater than 0, so that's all greater than 0, and a is greater than 0, show that b squared is less than or equal to 15ac. Okay, if this is greater or equal to 0, what can I say? So this means that there is only one root. Or sorry, no. This means that the determinant, the discriminant, has to be greater or equal to 0 as well. So in this case, b squared, so 16b squared minus 4 times 15a times 4c must be greater or equal to 0. So we're also given that a is greater than 0. So, and we can of course cancel this out. Oh, not that. This, and this. So we get b squared is greater or equal to 15ac. Of course, a being greater than 0. And so yeah, that's it, except that I think there's an error in the book because they put the sign the wrong way around, which is clearly wrong. So this is the answer. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next speedrun.